Today, I interview Thierry de Pauw. He's a consultant on continuous development and cares very much like I do, like we do at Interna, about how do you make product management engineering teams effective. We talk about mainline development and what that means, why that should make developers able to release code faster, get it out to users faster, and therefore find out whether the bets on the roadmap are right or wrong. We talk about a lot of other philosophical issues, but in heart, we're talking about making product development more effective. I hope you enjoy it. Hello, everybody, and welcome to the podcast. Today, I have the pleasure of talking to Thierry de Pauw, who I got to know through the Agile Alliance and presentation he did. Thierry is a thought leader in multiple things about continuous development, proper software development, process, and technique. But before we get started, I'm going to ask Thierry to say his name properly because I don't have those skills.
Yes. Hello, David. Thank you. My name is Thierry de Pauw. So it's a combination of French and Dutch.
So thank you. Well, before we jump into it, let's talk about your background. If you're like me, obviously process matters, but I didn't get there graduating from college and my first job in software development. I didn't know anything about the concept of process. I just knew how to do some coding. So tell us a little about your background, how you got here, how this became something that you were passionate about and started pushing.
Oh, all right. So my background is actually not computer science. So I have a degree as a Master of Science in electromechanical engineering. I was actually destined to study computer science until someone at university said, it's a lot of statistics, and I hated statistics. So I went for my second choice, which was electromechanical engineering, which is, big machines. And then I went for production planning for factories. This was my thing. And I actually started working in this industry. Like my first job was actually building a factory for an aluminium foundry. It was quite a thing when you leave college or when you leave university. And after that, I went working for a small medium enterprise, like 50 people. We were 2 engineers, and we did everything. We did R&D, the IT, the software. We built the machines. We did all the software for the human-machine interfaces, and that's how I got into IT finally. So 2 years later, I transitioned to IT. And that's
did you work in factories and process there?
Yeah, I worked in factories. Also as a student, I worked. So my student jobs was working in factories, which I really
did. The process you learned from working in factories and inferring there was maybe lean manufacturing, things like that, affect or help you think about process and software development, or were they completely unrelated?
No, well, actually, I learned all these things, and it's quite embarrassing. So I learned all these things in university. So we had theory of constraints at university. And my father was also working in a factory. And so he was like, this whole just-in-time thing doesn't work. When I look back, I'm like, yes, it did work, but you were just not ready for that. But in fact, I forgot everything about that. And it's only like 10 years later when I was cleaning the attic, I fall back on my courses from university and I was like, here it is. All the things I'm now hearing about. I actually learned these things. And then I started reading my courses, and I was like really absorbed by it.
Okay, so let's put a pin in that for a minute. I want to jump to another subject, and we're likely to circle back to this.
Mm-hmm.
So let's talk the purpose of software development.
Yeah, so the purpose of software development. Well, I have a take on this. It's like, the purpose of software development is actually to solve problems business has. And it might be that we can solve the problem without writing any software, which is the best thing. But if we do have to write software, we want to do this, in the fastest way, getting the fastest feedback. So we want to sustainably reduce the lead time to create a positive business impact. Creating positive business impact is when software helps the business and that the business can generate money. That's my take on it. So in the end, what we want is generating money.
So let me pause you there, because I think you and I agree on this. I think it's not surprising that we agree on this. This is why we're having this conversation. I have this thesis that all product managers are bad at their job. All product managers are bad at their job because it's not a job you can be good at. Where if good is the measurement of the user specifically wants this, and we specifically need to build that. It's an impossible job. And so if you believe that theory, and you believe the purpose of software development is creating value, which is, I'm rephrasing what you say, creating value for a user, which I believe too, then the thing that you're saying, which is, how do you reduce the lead time to get the knowledge of where the product manager made a good decision, where they made a bad decision, to iterate, right? So I think we're in agreement about that. Tell me if I'm wrong.
Well, we want to reduce the lead time because we want to know as fast as possible that the thing we've just implemented actually satisfied the user or not, or if the user is actually using what we have implemented, which is not always a given. Well, I've seen it many times happen that teams spend 6 months to implement something and then realize that nobody was actually waiting for this, which is painful. So that's why we want to reduce lead time. We want to know this as fast as possible, and we want to be able to course correct. And yet, in that case, product managers, it's always like making a hypothesis. I think the user might need this, but we are never really sure. And to know this, we need to have something in production, and then we need to measure.
Okay, great. So we have a hypothesis. Product managers are building hypotheses. I agree with that. I would say product managers are putting bets on a roadmap.
Yeah.
And until the rubber hits the road, until the user has a product you don't know, which then goes to, you're talking about reducing the lead time. So, so far we're in complete agreement. We'll see if that continues. Well, we'll see. So trunk-based development. Right. That's what we're really here to talk about. Mm-hmm. Trunk-based development, the process. Actually, I was going to define it. I'll let you define it for a moment, but then I'm going to be the contrarian I'm going to be a contrarian right after that. But define for us, if you could, trunk-based development.
Yeah. So, actually, not everyone is happy with this term, trunk-based development, because what we actually mean is continuous integration, but done right. That's the idea behind. But there happened some. The term continuous integration started to be badly interpreted. Many people say, we do continuous integration, but in fact they don't. And then somewhere around 2006, people started, especially the people from ThoughtWorks, started to say, but no, what we really mean is that we commit straight to mainline, which is trunk when you work on subversion, and we continuously commit to track. This is really what we mean. So it's not having a build system that is running against branches. That's the idea, and so that's why they wanted to make this distinction like, this is string-based development as opposed to continuous integration, as the whole industry was speaking about continuous integration, meaning we have a build server running against branches.
So building against trunk, right? So I'm gonna be the contrarian, and then tell me how I got this wrong, and then we can debate if we want.
Yeah.
Okay. So I got a bunch of I've got some user story that I've gotten from my product manager. I'm a software developer of some sort, and I want to do a branch. I want to develop on that branch. These user stories are small because I have a good relationship with the product manager. I have a good product manager. They're small and they're atomic, and so my branch is going to last for a day or two or three, and over those days I'm going to rebase from what's on main. Why is that evil? Why wouldn't I do that? And then me and a bunch of my fellow coders can all have our own branches, and we keep rebasing, and then we merge, and then life is happy. Why is that a bad idea?
Well, because we don't have feedback. So, that's the first thing. So we don't have feedback. As long as everyone is working on his individual isolated branch, they don't know how their work will integrate with the work of all the other things that are happening in parallel. And yes, you can rebase main onto your branch, but that is only main that you are integrating with your branch. You are not integrating all the changes that are happening on all the other parallel branches. So that's one. The second thing is, because they all work in isolation while we are hiding code. So I don't know what is happening on your branch, and I don't know what is happening on the branch of someone else. And so, when all these things come together, we might have some surprises, which can introduce rework, and this will increase lead time. So it takes longer to get into production. Whereas if we are all committing into mainline, we all see the changes of each other, and so we are communicating changes with each other, and so we can adapt immediately. Like, oh, this is happening there. I might need to change this and this and this. So it's more visible. And then there is a myriad of other problems, like it discourages refactoring. Because, once we refactor, we introduce new concepts and new abstractions, and this is difficult to integrate with other people because they don't have to refactor. So they build on top of other assumptions, but in the meantime, you have refactored code. Some concepts don't exist anymore, or new concepts have been introduced. And this can introduce semantic conflicts that are not necessarily merge conflicts. So it might be that the code merges correctly, but there is a semantic error because, concepts have changed meaning. And that you can only detect, if there are automated tests, we can have the chance to detect that. But if there are no automated tests, it's even worse to detect these problems.
So actually, you bring up we have like 5 things to discuss just from that answer. But I want to go to automated tests for a while because I find companies do this very poorly typically, and I would argue that without automated testing, it's very hard to have frequent releases, and therefore do the thing that we agree on, which is you want to decrease the lead time before the software is to the customer. You want to get that. So, is one trunk-based development or branch better or worse in a case where that you have low coverage on automated testing? And then how do you solve that problem in either case?
So, the low coverage by automated tests is problematic, regardless of if you use branches or trunk-based development. Yep. It's a fallacy to think that because you are using branches, you are protecting yourself against this problem, because the problem is still there. You still don't know if your changes broke something or not. So, but I hear this often. We don't have automated tests. Thus, we need to use branches. It doesn't change anything, actually.
I agree.
But that's a perception. Some people then think, but we don't have the pull request and the code review, but the code review will also not save you for this problem. I have yet to see someone detecting problems just by reading code. You will detect the obvious things, but not the less obvious things. What else?
I completely agree with what you're saying. I believe so. If you agree with me, which you may not, that many companies have a problem that their test coverage by automated test is too thin. There's just not enough.
Mm-hmm.
And in either case, if you want to decrease the lead time to deployment so you can learn faster, you would want to have automated testing. How do we create an environment where we generate automated testing? And that becomes part of what we do culturally, whether it's trunk-based or branches or whatever, doesn't really matter.
Yeah, so obviously, it helps to have automated tests. But I want to add a side note is that automated tests will just say that the thing we assumed it should do has been implemented as we assumed it should be implemented. But we don't know anything about all the things we don't know about the application. And this is where then exploratory testing comes in and will detect all these things. Now, this is a side note. So we need both automated testing and manual exploratory testing. Now, how do we create a culture for automated testing? Well, the only way I know about is that from the start, we say, as a team, we are going to apply test-driven development and acceptance test-driven development. So this means we have test-driven development that will create unit tests, and then we have the acceptance test-driven development that will create the automated acceptance test, which are also called like functional testing, but they are still automated. And that's how we will grow a test suite, and that we will have something that will be generally called a regression test suite. But it comes somehow for free, because it's part of your development process. It's not like an afterthought. It's not like, I've implemented this and now I'm going to add automated tests.
So we're straying from trunk-based development, but I promise we'll get back to it. Mm-hmm. So you have a TDD environment, or where people do TDD. That's accepted practice. Better to pair to make that happen? Doesn't matter.
Well, it helps. It helps at all the stages in the development process, because once we start pairing, the need for code reviews falls away, because we have reviewing while we are writing code. Also, while software teaming, more known as mob programming, also helps, and which makes string-based development even more easy, because we are going to work in sequences, like we work on this feature and then on this feature, So we don't have parallelism anymore when we do software teaming. But so pairing absolutely helps.
Hard to implement, at least in my experience. It's hard to.
It's a cultural thing, and not all organizations are open to it. I've had teams where I've suggested it didn't work, and then we look for other solutions. It's a cultural thing, and if you introduce it in an existing organization, it's more difficult. Whereas if it is present in the organization and you start recruiting, this is one of your requirements, do you feel comfortable in working in pair programming or in mob programming?
So let's go to the slightly harder situation. I am a new CTO in an organization that has some amount of legacy code because it's been around for 3 or 4 years, and there's no automated test suite or a small one. And I want to say, hey, okay, I'm the CTO, so I have the power to tell you to do whatever I want. So from here on out, everyone's going to do TDD and everyone's going to listen to me because I'm the CTO, and there'll be no problem with that. Let's just assume that's true. What do I do about the legacy code base?
Yeah, so the theoretical most ideal way of handling it is by using a concept that is called approval tests, also known as validation tests. So you start by setting up a test harness around what is visible of the application. Might be the user interface, might be logging produced by the application, might be just sending some input and you get some output. And so, well, you just record these things as is without thinking about it. And then you record it once, and then afterwards use that as a test. When we send this input, we receive this output. We have a test now. And once we have that, we can start refactoring in a safe way, because we now have this test that will eventually detect any problems. And then we can, and the idea of the refactoring is that we can introduce designs that allow us to introduce unit testing, because unit testing, requires that we decouple the code base. So this is the preferred way of working, but setting up approval tests is cumbersome. It's not always easy. I've done it against logging. Well, capturing logging is not evident. I've done it in C++. It's even less evident. And sometimes you just know what you need to do. Well, from my experience, I know what I need to do. When I look at the class, I know, like, okay, yeah, we are instantiating classes inside the method. Bad idea. We need to introduce dependency injection. Let's refactor until we have dependency injection. Now, there is a risk by doing that without tests. However, if we are able to do these refactorings in an automated way using tooling that does the refactoring, well, we are kind of safe.
Okay, so I want to pop back to, mainline development, trunk-based development, call it what you will. Mm-hmm. Okay, so we're all developing against, against the trunk, against mainline, and we're all developing there simultaneously. And we're all testing our code, and we're good testers, and it's a happy day. And we might be doing automated deployment. So maybe we're deploying every day, several times a day, once a week. I don't care. I'm halfway through my development when the deployment cycle goes. Mm-hmm. How am I protecting the product from my half-developed code?
Yeah, so the easiest way to do that, and people are most often surprised when I say that, you don't necessarily need toggles, feature toggles to do that. You might be able to just hide unfinished functionality. So for instance, we are adding a new screen to a user interface. Well, as long as the screen is not finished, we just don't wire the screen into the navigation. The screen is there, it's not finished, but nobody can access it. It's okay. Mm-hmm. Or we are adding a new backend service. Well, this backend service can be deployed as long as it is not used by a user interface. It's okay. Same for API endpoints. As long as there is no documentation about the API endpoint, well, nobody knows it exists. Can be there. It's okay. Now, the thing is, that doesn't always work. Sometimes we need to change a little widget on an existing screen, or we need to change the behavior of an existing backend service. And this is where then toggles comes in. That will help us in protecting us from ongoing changes that are not yet finished, but that allows us to deploy frequently, even when the change is not yet completely implemented.
Okay, so we have feature toggles. Feature toggles make me itchy.
Yeah, I understand.
Right,
there is a risk.
So, there's a risk. There's a code cruft. There's like people don't seem to clean them correctly. You just get a back end feature toggle debt.
Mm-hmm.
Do you have a good solution? I don't. By the way, I don't have a good solution to this problem. Do you have a good solution to this problem?
So, So we have an example of a company that went bankrupt because of a bad implementation of a toggle together with manual deployments. It's what happened with Knight Capital Services, which lost like $460 million in 45 minutes. Just because they reused the toggle between two releases and then they forgot to deploy on one server, on one of 8 servers. And then, crazy things happened. So most of the problems with toggles, and each time I suggest, toggles is a solution, and then people come to me and say, we tried toggles, didn't work. The problem is, teams don't manage their toggles. So we need to manage toggles. And the first thing is, like work in progress, we want to limit the number of active toggles. So as soon as a toggle is not needed anymore, we remove it from the code base immediately. Now, to keep track of these toggles, it's important to have an inventory of which toggles do we have. So, and to have tickets, and so, it comes with some administration. So this is one. Second, we want to also limit the number of toggles. And I've read some articles where they suggested we set a threshold on the number of toggles we want to maintain. Let's say we want maximum 5 toggles. Whenever a new toggle is introduced, another one needs to go. So it's a choice we need to make. When we say toggle, we also say branching logic, and branching logic needs to be tested. So we need to execute our automated test both against the toggle on and off. This is important. And then, branching logic means complexity in the code base, maintainability problems. So there are many ways on how we can implement this. So the most naive classic way is to use just an if-else check in the code base, like, is this toggle on or off? The most advanced way is to work with a factory and strategy in the strategy pattern so that we don't have conditionals anymore in the code.
Okay, I feel like I have not given you, I've not given you the opportunity to detail why feature branches are evil. We started talking about that. I played the contrarian a bit, but I don't feel like I've given you the opportunity to talk about all the reasons why you'd like to do mainline development. What else do we need to? What else do we need to say about that? I know there's a lot.
Yeah, there is a lot. I've written a whole article on the subject. It's called on the evilness of feature branching, the problems. It's quite long because there are many things that go wrong. So the first thing is, as I've already said, is it delays feedback. That's one. So the longer the branch is open, the longer that we don't receive any feedback. We only receive the feedback the moment that we merge back into mainline. That's when continuous integration kicks in. The second problem is the integration of multiple features that are being developed in parallel, but each on their own branch. So integrating this becomes exponentially harder with the number of features that are being implemented in parallel and the number of changes required to implement those features. I've already mentioned it hides work for team members, and so we are all in the dark of what is happening in all those parallel branches. It also working against adopting collective code ownership, which is one of the base values from extreme programming, which instills better code quality. Because, well, if everyone owns the code, well, it's easier to fix problems we detect, and to just say like, oh yeah, well, this is not code. I'm just going to change that because, well, I know this code. I also have the ownership. It's not the ownership of someone else. Whereas if we use feature branches, well, people work in isolation, and then we start to think like, oh yeah, this piece of code is their ownership, and this piece of code is the ownership of someone else. I've already mentioned that it discourages the adoption of refactoring. Then the thing is, and this comes from manufacturing, it induces batch work. And from manufacturing, we know that batch work is bad. So Toyota discovered that the bigger the batch sizes was, well, the lower the quality was. And that when they worked in smaller batches, well, they had better quality. And that they had faster feedback. They knew faster if a thing was right or wrong. But it requires skilled people and motivated people. So it requires a different culture to work like that. It also introduces more risks. Because if we work in branches, while we are accumulating changes on the branch, and the longer the branch lives, well, the more changes we are accumulating. And then all of a sudden, we are merging this into mainline. And so we are letting go a big amount of changes onto mainline. And eventually, this will be deployed in one go into production. And so if something goes wrong, well, finding the root cause will be more difficult because our change sets are too big. And so we will spend more time in recovering from an eventual failure. It's expensive also working on branches because we spend a lot of time keeping the branch up to date with mainline. It's the whole rebasing. And so every day you need to rebase, eventually fixing merge conflicts, reworking the code. And we don't keep it up to date with all the parallel branches. So it creates what Chris Altwood calls merge depth. So we are creating a depth of potential merging that will happen in the future, but we don't know how much work it will introduce. And so it makes the whole delivery process very unstable and unpredictable. And then it adds a lot of cognitive overload because, well, there is a lot of work that needs to be done on a day-to-day basis that engineers need to execute. So, well, they need to rebase mainline onto their branch to reduce merge complexity. When starting a new feature, they need to create a branch and then create a removed branch. If they want to communicate changes between features, well, they need to cherry pick commits between branches. And then once the feature is finished, well, we may not forget to delete the branch. So these are lots and lots of operations engineers need to execute. And so engineers need to know all the commands to execute those operations. Whereas with string-based development, it's fairly simple. We just pull the latest changes, add local changes, commit and push. It's the only thing we need to do. It's fairly simple.
So what about GitHub Flow? Right? It's neither fish nor fowl.
So GitHub Flow is somehow a sensible branching strategy. Let's say it's possible to be compatible with continuous integration, and it's according to
Actually, let me just pause because some of the listeners may not know what GitHub Flow is. So give, if you will, 30 seconds on what GitHub Flow is and how it's different from.
Yeah, so GitHub Flow is the branching strategy that GitHub started to use internally for their development process. So essentially, it means there is one long-running branch, the main branch, and then every feature is implemented on what is called a feature branch, supposedly short-lived. Now, there is quite a difference on how most organizations implement GitHub Flow and how GitHub implements GitHub Flow. And not many people are aware of that. So most organizations, what they do is they implement the feature on the feature branch, and once the feature is finished, they merge to main, and then deployment happens from main. Whereas GitHub, they deploy from the branch, and they only merge into main once the deployment was successful. The rationale behind this is that if something goes wrong in production, they can roll back by redeploying mainline into production. Now, the result of working like that is that they need to sequence merging of their branches and releasing of their features. So it's one branch at a time that is deployed into production and then merged into mainline. Where most organizations will merge multiple branches into main and then deploy multiple features at once into production.
So when would you say GitHub Flow is the right thing to use? When would you say mainline development's good to use? And then, just to be possibly contrarian, when would you pick feature branches or never?
So it quite depends on my role in the organization. So I've always said
you're God. Even if you get to be God. Your role in the organization.
Yeah. So like if I would be in charge, there's no automated test. I would just tell the teams, we're doing crimp-based development and we'll fix it. I'm aware it will introduce quite some stress, but at least it has the benefit of a way forward and imposing change, because all of a sudden teams will have to do something about everything that is wrong. Because then they will have to look for, but how can we do this in a less risky way? Maybe if we work in small increments, this is less risky. Well, here you go. You work in small incremental steps. Mm-hmm. This is one way to mitigate the lack of automated tests, because now, I change this, what happens? I change that, what happens? You're more in control. It's not like you're releasing a bunch of changes all at once and then, something goes wrong. What might this be? We did a lot of changes, damn it. So this is one way. If I'm consulting, coaching, it's different. And then I'll say to them, stay on your branches. It will feel safer for you. And we'll start working on implementing automated tests.
So, and then eventually go to mainline development. In that case.
Wow. So the thing is, what I suggest is start collecting metrics about your build system, like what's the lead time of your build? What's the failure rate of your build? If it fails often, it's not good. Something is odd. If it doesn't fail that often anymore, you're going in the good direction. And then also collecting metrics about branch lifetime, like how long are the branches open? If this is starting to reduce, which we want, this is going in the good direction. Eventually, at some point, we can say, maybe we don't need branches anymore.
And when would you say GitHub Flow is the way to go as the end state?
I see it as a transition to string-based development because, so what we say is like an organization is in a state of continuous integration when everyone commits at least once a day into mainline, which means, we are merging branches at least once a day into mainline. And then there is also the thing that, every commit triggers an automated build, and when a build fails, we can fix it within 10 minutes. So these are the conditions for continuous integration. Now, my take on this is, if we manage to keep branch lifetime reduced to a couple of hours or maximum 1 day, why would we bother to still create branches? Because it's an administrative overhead. Why would we still do that?
Oh, right. Okay. So basically, if your branches are short-lived enough, the problem solves itself. And so you don't need them.
Yeah. Exactly.
So what is the big... I have a 2-part question. You can answer the parts in any order you want. The questions are, what's the biggest resistance to do mainline development, trunk-based development? And talk a bit about your consulting and how you help companies be more effective in doing software development.
So the resistance is mainly they don't know. The whole industry is using some sort of branching strategy. And it has been popularized with GitHub as a development platform, and it was popularized especially for the open source industry, where it really made a difference. Because and I'll remember that we were sending patches over email. Now we had this and then we applied the patch on the code base we had, and then we start. And I'm reviewing the code. It's an interesting way of working. Of course, the pull request model made total sense for the open source world. But now we have a whole commercial IT industry that started adopting this open source model, which makes absolutely no sense for co-located corporate environments. Because, the open source world uses this because there is a trust issue. So we want people to contribute code, but we don't know the people that contribute code. So we want to verify the code they contribute. Makes sense. In a corporate environment, we are working in teams. We know the people that are working in the team, and they all are supposed to be owner of the code. So there is no trust issue, or there shouldn't be a trust issue. So everyone should be able to commit into mainline. But most often, people are afraid that, it's going to be a mess. And most of the time, it's because they lack certain software engineering skills. And once you start showing them those engineering skills that make the difference, then they start to get it. But you need to sit next to them, show how to work. And once they experience the difference and how much more easy the workflow becomes and how much more simpler, most of the time they cannot imagine going back to branches. And just one case I like to tell. It's a French engineer who was used to work with branches all his career. And then he enters quite advanced organization, quite extreme programming oriented, that did string-based development all the time. And when he arrived, he was like, no, this cannot be possible. This cannot work. And 1 year later, he's one of the biggest advocates of string-based development on LinkedIn. And because he experienced this, saw the difference, saw how much simpler everything was, and also saw how much higher quality is delivered, because it imposes a certain way of working. So you need to adopt certain engineering skills that will lead to better quality.
So back to the second part of the question. In your consulting, talk a little about your consulting, what you do, and how you help companies create more effective software development organizations.
Yeah, so my consulting is well, it started to be focused on the adoption of continuous delivery, and so improving the whole delivery process. But most of the time, it starts with adopting continuous integration right way and solving the problematic branching strategy that is in place. So most of the time, they have a crazy branching strategy in place. And then you start asking, why is this in place? And most of the time it's a fear thing. And then you start working on this. How can we mitigate this fear? What would help? And then, well, I'm most of the time there to explain principles and practices and show them different ways of working. Sometimes I'm just sitting next to them, like, show me the code, which is sometimes surprising because you never know how the code will look when you see it. So it's unprepared, and then you get this code in front of you, and you have like 10 seconds to make a reasoning like, I think you are lacking this. Well, and then you start to show them like, well, most of the things that are missing is dependency injection. And they just don't know this concept, dependency injection. And then you show them like, look, when we do this, now we can test this piece of code in isolation.
Yeah.
And then there's a big aha moment.
So it starts with the tactical and goes with the conception. It goes to the conceptual and cultural.
Mm-hmm.
So one last question. CodePilot, Code Whisperer, all those code generation tools, do they change any of this? Or is it all just the same from continuous development?
So what I think it will change is that all the repetitive work, all the boring thing will be generated by artificial intelligence. But which also means that the need for specialists will be fewer, but if we will need even more generalists, people that know about a broad area of, a broad expertise, not really in depth, but really have an overview of everything that is required to release an application, just to judge what has been generated by the artificial intelligence. Because in the end, well, it's still computers that are generating code based on models that has been defined by humans.
So I said that was the last question. Clearly by this next one, it wasn't. I claim that these Gen AI tools empower the senior developer and are either do nothing for or scary to put in the hands of junior developers because they can't judge what was created and senior developers can't. Yeah.
Exactly. So I don't believe they will suddenly start generating applications. We've been there before. In the early 2000s, the same was said about the case tools. That business would be able to just create an application by clicking around and then, oh, here you go. You have an application. Didn't work. I still don't believe this will happen. It will facilitate our work. That's true. But it won't replace software engineers.
So how will we train junior engineers to become senior engineers in the world of code assistance tools?
Well, the same way as we trained them in the past by having a senior sitting next to a junior. It's expensive, but it's in my experience the best way to train a junior. During 6 months, you have a senior sitting next to them, showing ways of working, and that is okay. And then they are at a level where they can start reasoning and argument with seniors. And this is wonderful. I've seen this happen, like people in 1 year time getting at my level and starting to read books, and then starting to oh, I've read this, what do you think? And I found this book, have you read it? No, I didn't. What do you think about it? And it's wonderful.
So, Thierry, thank you very much. I posed this conversation at the beginning about some things we agreed on, and then I took the contrarian view of things that we, in air quotes, didn't agree on. But as you know, as I think people listening to this will learn, that we agree on many, many things, and including that last statement about the necessity for senior programmers and the training method for junior programmers probably not changing very much. So thank you very much, and appreciate you spending time with me.
Thank you for inviting me.